Hi, this is Kyle Houches. I'm a technical trainer for McNeil, and today I wanted to talk about a part that came into our forum. There was a post about this part and essentially shelling. And shelling is something that comes up a lot with Rhino. There's some good things and some bad things, and I just wanted to kind of talk about how to approach a part like this. First thing we're going to do is we're just going to run the shell command. And if you didn't know there's a shell command, there's a shell command. The thickness, we're going to do 2 units because this part is in millimeters, which we can confirm down here at the bottom of the page. I'm going to pick these 2 faces and we're going to run shell. Now, before this runs, I'm going to tell you it's going to fail. And there's a number of reasons it's going to fail, and we're going to talk about that kind of going forward. The main thing we're going to focus on is not necessarily the fact that it failed or why it failed. We're going to figure out how to fix it and how to get, the result that we're looking for. So I'm going to run shell. It's going to do its thing. And just like the user experience, they get this warning that says shell is not solid. Now, at this point, you may want to throw your arms up and get on the forum and tap off an angry note and tell us how terrible we are. Feel free if that's what you need to do. Knock yourself out. The reality of the situation here is if we look at actually what Rhino gave us and we turn on naked edges, we can see that actually this is not so bad. We can actually work with this. One thing to keep in mind with this file is in millimeters. I haven't done anything from when the user sent it, and I'm not bashing the user in any way, shape, or form. This is just the reality of kind of how things work sometimes. If I go up here and I say Tools, Options, I'm on Windows, by the way, Units, you can see that in millimeters, we are at 0.001 units. Now, what happens if we were to change this from 0.001 to 0.01? And you say, Kyle, why would you do that? You can't change tolerances in the middle of a file. You actually can. There's an asterisk, though. You can only make it looser. You can't make it tighter. So we can't go from 0.01 to 0.001 and expect anything to happen. We can go from 0.001 to 0.01, and if we explode this part and then join it again, it's still going to come back as an open surface, and we may still have the same problems, although you'll notice this surface isn't a problem anymore. Okay, so let's go back. Actually, I'm going to go back to the very beginning. I'm going to revert this file. And just because I haven't done it, I'm going to experiment here. Come along this journey with me. And we're going to actually change the tolerance to start with. And the reason that I'm going to do this is because 0.001 millimeters, if you look at that on a set of calipers, is really, 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 really tiny. Now, it's entirely possible that the user needs this tolerance. And if that's the case, then ignore pretty much everything I'm going to say for the next couple of minutes here. But if you don't, if this is like kind of a standard part, 0.01 millimeters is probably just fine. Now, the thing that you need to keep in mind is if this part is going to SolidWorks, if this part is going to ProE, if this part is going to NX, if this part is going anywhere else after you're done with it, the tolerance that you should be working at is the tolerance of the piece of software that you're trying to transfer the part to. In SolidWorks, I don't know what the tolerance is, but it's like 5 decimal places. You need to talk to whoever it is that's going to work on this part after you, find out what their working tolerances are, set up your file before you draw the first line to have the same tolerance, and then work at that tolerance, okay? So I just want to get that out of the way. But in this case, let's just assume that we're handling this all the way. And if we go Tools, Options, Units, and we change that to 0.01, and we run the shell again at 2 units, it's entirely possible that it's going to fail again, but we might get a little bit different failure than we did last time. And it does look like it failed. If we look at show edges, we can see that this part actually shelled successfully where it didn't last time. And it's entirely possible that all we need to do is work on this part and this part. And probably the way to fix this is to let's just for curiosity's sake, let's pull this part out using extract, and I'm going to hide it. And then let's pull out this part and this part. And just for curiosity's sake, let's just join them back in and see what happens and see if they actually will join. And they won't. So the easiest thing for us to do, and you can see why this failed. You can see that this surface didn't trim correctly. And so what we can do is we can do a couple of things. We can extract this surface and this surface, and take a look at them. And we can start to do a little bit of investigation. The first thing we might want to do is maybe we want to trim this thing so that it actually does trim. And so what we could do is duplicate an edge and then look at just this. And we could extend curve on surface. This is the curve to extend. This is the surface that it's on. We can then trim. Let's bring this part back. This is a symmetrical part, by the way, so chances are this thing is going to join, side to side. So if I get one side working, I'm probably going to just fix the other side. And you can see that this edge now joined up. And it's possible now that this edge will join up. Let's take a look. And it looks like it's not. So we have some choices to make here. And it looks like the problem child is back here. If I go to wireframe mode, you can see it. See that little mess right there? It's entirely possible that if we extract just that surface and we split it by isoparam, and we snap to that edge, that I can pull out just the problem child. And then that leaves me with a really nicely structured four-sided opening that I can just go in here and do a 2-rail sweep. And I'm going to join that in. That joined up. So our problems are going away slowly but surely here. The next thing I might want to look at is this surface in here is pretty complex. And you can also see that the opening around it is kind of messy. And so what I'm going to do is I'm going to split this by isoparam. And I'm going to snap it to the last known good point, which is right here. And then I'm going to delete this piece. And I'm going to join this in. I'm trying to do as little, work on the part as I can in order to be able to get a result. Now, I've got a little bit of a messy, I'm going to shut some isoparams off so you can see what's going on. I'm not actually changing the surfaces, I'm just changing the isoparam display so that we can see what's going on. And I did that by picking the part, going to the properties, and then coming down here and saying show surface isoparams. That gets you a little bit better view of what's going on. And I can see what's going on here. I have an opening that goes from here to here, and then it comes down this edge and here to here. So I've got actually an end-sided opening here. Now, if I wanted to make Sky Greenwald have a stroke, I could just throw the patch. I could throw a patch in here, but he's probably just had chest pains and doesn't know why. So I'm not going to do that. What I'm going to do is I'm actually going to break this edge up into something that makes a little bit more sense. And you can see one of the problems is right here. And so what I'm going to do is I'm actually going to extract this surface, even though it's, quote, good. And then I'm going to come down here in the edge tools, and I am going to grab this merge edge tool. And I'm going to merge this edge back up so that it's one complete edge. Then I'm going to go back and do another 2-rail sweep. And I'm going to just run that, and I'm going to join it up. And you can see that that pink has gone away. There's a curve here, so I'm going to delete it so you can see it. And now we've still got this kind of end-sided patch going on. So the next thing I'm going to do is I'm actually going to go back to the edge tools, and I'm going to split the edge, and I'm going to use an O-snap to snap it over here, and I'm going to break this edge now into 2 pieces so that it matches that edge. I'm going to do a 2-rail sweep. And I may need to adjust, the tangencies or all that kind of stuff. I'm not entirely sure what the intent of the part is. I can play with tangencies and all that kind of stuff, but I think I'm just going to run it at position just because I don't necessarily know what this part is supposed to do. So I'm going to just run that, and I'm going to join it up. And you can see that the pink, which is the naked edge, is starting to go away, and I have a 4-sided structure left that I can simply just use an edge surf. I can use a 2-rail sweep. I can use, anything I kind of want in order to close this up. I'm going to go ahead and close it up just with 2-rail sweep. Join it up. I'm going to go to the top view. I'm going to split this in half with a center point curve. I'm going to mirror it over. I'm going to join it up. And we get a closed poly surface. If I wanted to go one step further, I might run merge. I might spell merge right. Merge coplanar faces, merge all coplanar faces is what I'm looking for. And let it go ahead and, clean up the flat bits so that there's no center line down here. So this now gives us a closed poly surface from, what we had to start with. Now, if I turn the isoparams on, you're like looking at it going, wow, that's really clean. No, it's not. Here, I can turn the isoparams on. It's just as messy as the original one. Now, if I was going to do this for a client, I would take a look at this part and I would say probably this surface, that one, this one, that one, and that one. I would probably actually go through the process of rebuilding those so that they're a little bit cleaner. There's no reason that this surface needs that many isoparams. The reason it's got that many isoparams is because it's technically an offset of this surface. And this is a fairly complex surface to start with. And so once you offset a complex surface, it gets even more complex and all that kind of stuff, right? So if I was to do this part myself, and like I said, this is no reflection or bash on any of the original creator of this part, I would probably go through the process of kind of single spanning this thing as much as possible. So I would probably go through and I would rebuild this area. I'd probably rebuild this surface in here. I'd probably do it in a way where, these blends are connecting a little better, and I would clean this surface up and I would kind of single span this as much as possible before I did the shell. That way, the resulting shell would be simpler and the surfaces would be a little bit easier to work with. All that said, right, we can talk about like how it would be great in a perfect world, but in this particular circumstance, this is totally salvageable. Like there's absolutely no reason why you can't just come in and fix this stuff. And the difference between the way Rhino's shell works and like say a parametric modeler like Pro-E or SolidWorks or something like that. First of all, they're using a completely different geometry kernel and it works completely differently than a surfacing kernel that like we use. But what happens is essentially the entire model gets offset inward. And then all of those offsets get trimmed, and then they get unified, and then it tries to connect it, and then a whole bunch of stuff is happening in the background. But at the core of what's happening here, it's an offset. So anytime you get an offset that makes an overly complex surface or the points of a surface bow tie on each other or anything like that are all things that contribute to why shelling fails. You're going to have to talk to somebody a lot smarter than me to figure out, how to fix that particular issue. The thing that I'm trying to show you is that what Rhino is essentially doing when it does a shell is it will actually go through and do the shell. I don't know if you remember that old Monty Python skit where the marathon runner comes in and says, "Message for you, sir," and the arrow hits his chest and he falls over dead. That's essentially what Rhino's doing. It's like, "Shell for you, sir," and then it falls over dead. And then you're left to kind of deal with, what's left. But 9 times out of 10, if you look at it in a way, instead of just throwing up your hands and frisbeeing your laptop across the room and saying, this is terrible and I hate my life. If you just look at what's there, it's usually pretty easy to fix. And I'll put a couple of links in the description of this video when it gets posted. I did a video called Watertight or File Repair for Watertight Parts, or Watertight Repair for File Parts, or File Watertight Repair Parts. I can't remember the name of it, but it'll be a link in the description. That process is the exact same process that you use anytime you try to go in and fix this kind of stuff. So that's about all I have to show you on this part. I just wanted to have a little discussion about this to show you that the results that Shell gives you may be a lot more useful than you originally see. Hope it's useful. Hit me up in the comments. Let me know what you think. If you have any problems or files that you want to share or need help troubleshooting your own stuff, hit us up, tech@mcneil.com. You can make it attention to Kyle, and we'll take a look at it and see what we can do to help you out. That's about it. I'm Kyle Houchins, tech and a trainer from McNeil. This is trying to figure out how to make your shell parts actually shell parts instead of messy naked edge parts all over the place. I'm going to work on the title a little bit. But with that said, go make great stuff. Thanks. Bye.